This lecture will immerse us in the world of the basic building blocks that make up everything, atoms and their even smaller components. We will learn about the Coulomb force and how the elements are categorized in the periodic table. We will look at the Bohr-Rutherford atomic model and learn what ions are. Even though you might think that these things don't really belong in an electronics course, you'll understand why we need to learn them at the next level. Our world, everything you see, consists of extremely tiny building blocks, the so-called atoms. Their name comes from the ancient Greek word atomos, which stands for uncuttable. Previously, they were thought to be undividable, but scientists found out that they consist of even smaller units. These units are called protons, neutrons, and electrons. The protons are charged positively, the neutrons are neutral, and the electrons are charged negatively. An atom can be divided into a core and a shell. The core, or nucleus, consists of neutrons and protons and makes up more than 99% of the weight of the atom. The shell, on the other hand, consists of electrons and makes up the majority of the volume. As the neutrons aren't charged and the protons are charged positively, the net charge of the core is positive. You might instinctively know that similar charges repel each other while opposing charges attract each other. This is why the electrons are attracted to the nucleus. The force that acts between them is called the Coulomb force. As we see, the force decreases with increased space between the charges. Further, it increases with the charge of the elements. The larger the charge, the larger the force, and the greater the distance, the lower the force. Another thing you might wonder about is why the protons inside the nucleus do not repel each other due to the electrostatic force. This is because there is another force present, the so-called nuclear force. This force is magnitudes higher than the electrostatic force, yet it only occurs at very small proximities like those found in the core. Each atom consists of at least one proton in the core. The number of protons in the core significantly changes the properties of the element. This is why humanity came up with a way of classifying these elements with the so-called periodic table. An atom with one proton, for example, is referred to as hydrogen. An atom with two protons, on the other hand, is called helium. One with 3 protons is lithium, and one with 4 is called beryllium. The number you can see in the upper left of the periodic table elements is the atomic number, which is equivalent to the number of protons in the core. Now there are also different models with which the layout of the atom can be described. One of the first and simplest description was the one of Rutherford and Bohr. In their model, there are different shell layers. Each shell layer can only contain a specific number of electrons. This number increases with the shell number after the formula 2n squared. This means that there can be a total of 2 electrons in the first shell. 2 times 2 to the power of 2 is equal to 8 electrons in the second shell, and 2 to 3 to the power of 2 is equal to 18 electrons in the third shell. The higher the shell number, the higher the energy that can be stored in the shell. The shell with the lowest energy is always filled first. So the next shell layer is only opened when the previous layer is already full. It is important to understand that every atom wants to have a full outer shell layer of electrons. These outer shell electrons are called the valence electrons. Let's take a look at the periodic table again. The rows in the periodic table represents the number of shells each element has. So if an element is listed in row 2, this means that it has a total of 2 shell layers. If it is listed in row 3, it has 3 shell layers, and so on. The column of the periodic table represents how many electrons there are in the outer shell layer. This means that the elements on the far left have only one electron in the outer shell layer, while the ones in the far right have a full outer shell layer of electrons. The ones in the far right are called noble gases. These are called noble because every element wants to achieve the condition these elements have. The elements in the periodic table are also separated into different groups. In its basics, there are nonmetals and metals. Metals usually have relatively few valence electrons, while nonmetals are usually rich in valence electrons. This basic differentiation will be important for you to understand the concept of conductivity later on. Finally, for this level, let's talk about ions. Normally, each atom has as many electrons in the shell as protons in the core, which means that the net charge of the atom is neutral. However, if we add or remove an electron from the shell, we get a charged atom, a so-called ion. An atom with an added electron in the shell is net negatively charged as the number of electrons is higher than the number of protons. This is called an anion. An atom with removed electrons, on the other hand, is net positively charged. We call this a cation. Okay, so let's summarize what we have learned in this level. Our world consists of atoms, and these atoms consist of a core and a shell. The shell is filled with electrons, while the core is filled with protons and neutrons. The electrons are held in the shell by the attracting electrostatic force that occurs because of the opposing charges of the electrons and the protons. The protons are held together by an even stronger force, the so-called nuclear force. Depending on the number of protons, you get different elements. There is the Rutherford-Bohr model, which describes the shell of an atom to consist of layers, while the electrons that sit in the outer layer are called valence electrons. Every element wants to achieve the condition the noble gases have, a full layer of valence electrons. Further, there are ions, which result of an imbalance between electrons and protons in an element. The atom can either be charged positively, cation, or negatively, called anion. The full course is available on Udemy.